Wouldn't it be a good part of one of those end of the world movies if the main character was just driving in reverse, like on main roads, and they're like, I always wanted to do this. That's what's been top of mind for me today. How about all of you on this leaded adventure? Um, yeah, so it's been a pretty good day. I just went to a thrift store, found some leaded items. What's up, Rusty? I hope you're having a great day. Found a bunch of like probably 150 pounds of dishes. I don't know what the hell I'm gonna do. You can't hear me? You're kidding me. Oh, you can hear me. Your sound is off. You gotta turn it off though. So yeah, no, that's the story. I got a meeting right now with a doctor. He's a pediatrician, and so my scheme here's my plot to end lead poisoning. It's to equip this guy with fluorospec, and then he's a prenatal care provider, so he serves Medicaid enrollees. So what he can do is he can give them a fluorospec kit. They can, in theory, take it home, use it, find if they have a lead hazard, and then bring it back to him empty. And he can sit there with like 1 gallon of the fluid that I now can make for an even lower cost, and he can refill the bottles. And so there's no like shipping, there's no reusing, there's no more flashlights, there's no more kits. It's all the same thing. So the idea behind this is that the price per use of the test kit will reduce in a hyperbole, which is like a parabola, but it goes down, but it never touches zero. So it will go as down as it can towards the cost of refilling the kit, and then it'll just sit there. And so all these people who have these children gestating inside of them that will soon be roaming throughout their environment that typically get exposed to lead and then get tested for lead, and everyone's like, oh, we tested for lead, that's great, because most states don't even have universal child testing for lead. They find out that there's lead through the kid, and that's like the worst way to possibly do it. It is totally insane, and the industry has actually been dominated by a company called Magellan, who had several of the executives get charged with criminally misrepresenting what the test could do, the Lead Care 2 machine. It was like fraudulent. They had to pay like $20 million, and I guarantee you they still made money on this machine. That's how like ridiculous. There's so much money flying around, like around lead, testing it, remediating it, but like most of it is just wasted because it's just not well thought out, because the industry is dictating basically the terms of engagement for everybody. If something like Lead Care 2 exists and then they say, oh, well, this is the only thing that's FDA approved, well, good for them, I guess, bad for us. There's never been any real competition in the space, even the XRF industry. There's really only like two companies, and they both work. Both the people who made those companies work for the same place. Um, so hopefully it's not breaking up for everybody. But those are my plans. Those are my schemes to help end lead poisoning. I have one thing cooking in my warehouse right now. Tiny little specks of lead attractant, mesoporous. It's not mesoporous, but it's tiny little pores, 60 angstroms wide. They're like little tunnels, and they're coated with these sulfur bonds, and they attract lead from the water, and then they hold on to it. So what I did was I made a stencil using a laser cutter to cut out a piece of tape, and then I took a little bit of crazy glue and I brushed it onto that little dot, and then I pulled off the tape, and now there's just a tiny ass dot of, excuse my language, tiny dot of glue, and then I pushed it onto a pile of this powder that I prepared with the sulfur bonds. So now when water or anything else, a liquid medium containing lead, contacts that surface, the lead will attract to that dot. And since I've done this research on lead dust particles fluorescing, and I know the minimum size, it's pretty small, like half the width of my pretty fine hair, 40 nanometers. Typical human hair is 70-ish nanometers. So I can now assume that the dot will glow really bright. And like I've taken pictures, I've done stuff with it, I've proven that it works. But like it's on these like shards of like microscope slides, and it's not very impressive looking. So I haven't made any content about it. And like it's kind of hard to like make a video when I'm like kind of like anxiety stricken with like doing the research. I'm like, is this gonna work? Now I gotta wait X amount of time. What am I gonna do? I'm making a mess. So it's getting close though. Just to wrap it up, if anybody's any questions, I'm going to. I had such a great idea last night. Food testing for lead. mostly has been done. Whole Foods have been tested in mass by the FDA in 2020, I think. They spent millions of dollars and they tested 20, 25, 30 of the same thing. Potato, 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 french fries, french fries, french fries. And they found, there's lead in some stuff, there's not lead in other stuff. Almond milk, regular milk, meat, fish, other dairy products, cheese. And, some of the stuff is surprising, some of it's not. It's all on bloodleadcalculator.com, which is a website that I made that I would really love for all you to use and to just check it out, and let me know what you think. Because I think that presenting the information in a way that indicates how much lead you actually are exposed to is incredibly valuable versus a concentration. For example, if I said, well, I drank some 80 proof alcohol, how would you know how drunk I am if I don't tell you how much I drank? And here's a follow-up question to further elucidate this point. If I drink 80 proof alcohol and then I drink beer, which is like, let's say like 8 proof, which is going to get me more drunk? It all depends on how much I drink. If I drink a teaspoon of the liquor and then I drink 5 coffee cups of the beer, obviously the beer is going to get me more drunk. And the same is true for lead. If you have a lot or little parts per billion or parts per million, if it's like something like spices, it all depends on how much of it you actually consume. It doesn't, we don't consume a concentration. We consume an amount. And so there's another company called Oasis, and they make like a food app that does like dietary stuff, and they talk a lot about heavy metals in there. They also took a lot of information. They didn't do the FDA stuff. They just took all of Tamara Rubin's research, and they actually bizarrely co-signed her 5 parts per billion is like a limit that we should be concerned about. And like, I'm not saying that, kids should be consuming baby food with lots of lead, but it was a proposed action level like 4 years ago for baby food. And baby food is so different than spices, than sea salt, than supplements, than stuff you don't even ingest. You just put on your body. Saying that 5 ppb is equal to 100 is completely idiotic. And that's like the secret truth behind the lead reporting, is that it doesn't make any sense. And nobody would know it doesn't make sense because nobody is aware of the intricacies of the science, because it is pretty complicated. Take this, for example. Suppose you have, and this kind of harkens back to the example of the alcohol consumption. Suppose you have a can of soda, let's say it's Olipop, something I'm currently testing. But I'm not just testing the Olipop in its native form. I've evaporated 90% of the liquid. So now that Olipop is 10 times more concentrated. So when I send it to the same lab that Tamara uses, which costs $80 a sample, instead of getting a 5 parts per billion on the total, I'm going to get a 0.5 parts per billion because I'm sending them a reduced fraction of the liquid. So all that lead has become concentrated. Just like if you have a gallon of salty water from the ocean and you boil off the water and you only have a cup left, that water is going to be super salty. So when we take this and take it in, weave it into the account of lead, we'll find that there's going to be a concentration of lead that can be found when we reduce the weight of the material. So I got a great plan for all Whole Foods too, because like, baby carrots tested by the FDA, 6 parts per billion lead on average. That's like pretty significant. If you eat 100 grams of that, you're getting over half a microgram of lead, which like for a little kid, like probably want to skip it. But there's a lot of things that test like non-detect if it's below 5 ppb. So like back to the example of the Olipop. The Olipop can is 350 grams. So if you consume 350 grams of a liquid that has 1 part per billion, you'll get 350 nanograms. That's approximately the same amount of lead as is in Lunchables. And remember Lunchables have lead in them? Oh my gosh. It's like nationwide news. But like Olipop, which is declared to be safe by everybody who tests at 5 ppb and doesn't know about how science works, easily contains more lead than a Lunchable. And like, you don't just drink one Olipop, you drink like 4 of them because they have very little calories, and you're like, this is healthy. But, I mean, are you going to get lead poisoning from that? I don't know. The straight dope on how much lead poisoning you actually get from consuming lead is It depends on the amount of lead that you consume, of course, right? You don't consume a concentration, you consume a quantity. So if you eat 1 microgram of lead and you're a child, you'll get an increase in blood lead of 0.16 micrograms per deciliter, which is an insane way to say 16 parts per billion in your blood. So a deciliter is 100 milliliters. A microgram into a deciliter is 1 microgram per deciliter, and that's 10 parts per billion per one, because 1 microgram per liter, which is 1,000 milliliters, is a part per billion. So who knew? There's 1,000 micrograms, there's a billion micrograms in a kilogram, and a liter of water is 1 kilogram. So, with all that being said, and I'm sure I'm not losing anybody, it's imperative to understand the total quantity of lead you consume, because then you can extrapolate how much lead you actually are going to wind up with accumulating in your blood over time. So the FDA did 2 well-funded, well-thought-out research studies, and they did them twice. They did the first one because they wanted to know this information. They did the second one because they were like, is that even good enough? So they determined that, yeah, children will increase their blood lead by 0.16 micrograms per deciliter for every microgram of blood they consume every day, and then the adults will get 4 times less. And this is like an average, obviously. If you have a kid who's like 4, they're going to get way less lead increase than a kid who's 2 and weighs like a third of their weight. And so there's like more nuance to all this stuff, but as a general rule, adults get 4 times more consequences, 4 times less consequences than children. So all of this is available on bloodleadcalculator.com, and I think that that's a really good tool. I'm going to leave this on my channel. Maybe I'll post this to YouTube too, because I think that this information is pretty valuable. It's just like, it's a complicated topic, and for me, this experience has been really like emotionally charged due to the fact that there's just so many people with so many completely different opinions than mine. And when I say it's an opinion, I would say it's more of an objective fact, because I don't really care one way or the other. I just want to help end lead poisoning, help prevent people from getting exposed, and I want to sell my product and grow my business. So that's where I'm coming from. And like, I guess my biases are, in terms of like, I promote FluoroSpec, whatever, but hey, I wouldn't say that other tests are like the worst if they weren't. If they didn't have less chemicals just to avoid the laws, if blah, 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 like if they weren't not as strong, I'm not going to lie. And that's the thing, like, people be lying, and it's pretty bizarre, because like, you're going to get caught eventually. But the thing is, a lot of people, I think, in this industry, they just gotten away with functioning at like the bare minimum for so long. So like, they don't break the law, they just show up. Who cares if they're only half right? It doesn't matter, because nobody understands this stuff anyway. So I'm on a quest to understand everything, so we can really get to the bottom of like how the kind of like microcosm of events transpires to give people exposures that impact their blood lead to the extent that it's going to give them ADHD, cardiovascular symptoms, that it's going to cause the CDC to show up at their house and declare, you got a major problem on your hands. And then, induce panic in the person who has a child, or the adult who's getting clogged veins. And, it's even easier to not ask for, you're right, like not, ask for, say, I'm sorry, or just get permission, but you'd have to understand. And I really believe that a lot of the people just can't understand. That's like the conclusion that I'm kind of getting near, is like, it's just too complicated. They're too uninterested in this, and they're not getting into it for the reason of like, I'm super obsessed with this topic just because that's just the way I am, and I can see through it all. So I just got home. I have a meeting with that doctor. Thanks for watching. Let me know in the comments what you think. Ask me more questions. I will answer them. And watch out for a video that I edit, because I did go to a thrift store today, and I made a cool video about airplanes, which release 800,000 pounds of lead per year, which is insane. And it'll do that until 2030. Supposedly, that's when they're going to remove the lead from the gas, from the AV gas. Blah, blah, blah. All right. Thanks for watching, everybody else.